plus x whole square is equal to a square plus 2ab plus b square. So there we have three terms in the binomial expansion and we have one middle term. So again, as you know, a plus x whole square, whenever we have an exponential power of n, then there are n plus 1 terms in the binomial expansion. So the number of terms will automatically be n plus 1. This does not depend on whether n is even or not. Irrespective of the fact that n is an even or not, whatever be the exponential of the binomial expression, the number of terms on the right hand side will be 1 plus that exponential. So the number of terms in the binomial expansion of a plus x whole to the power n, where n is an even integer, irrespective of that, we'll have the number of terms as n plus 1. And since n is an even number and we have replaced n equal to 2m, we have n plus 1 equal to 2m plus 1, which is actually the number of terms in the right hand side binomial expansion. Now, if 2m is an even integer, then 2m plus 1 will be an odd integer, because 2m is an even integer and 1 plus any even integer will be odd integer. So this is essentially an odd number. And as we know, an odd number, for an odd number of terms, there will definitely be only one middle term. So that middle term will essentially be the m plus 1th term. You see, if we have 2 as the exponential, then in this case 1 is actually m is actually 1, because n equal to 2, so n equal to 2 into 1. So in our case, when we consider the situation where a plus x whole square is the binomial expression under consideration, then m equal to 1. In that case, the middle term will be the second expression, which is 1 plus 1th expression. So it matches. Now this m plus 1th expression is the middle term. It is given by the fact that there are m expressions to its left and m terms to its left and m terms to its right. So m plus 1th term becomes the middle term of the expansion. Now m plus 1th term is also n by 2 plus 1th term, because if n equal to 2m, then m equal to n by 2. So the m plus 1th term is essentially n by 2 plus 1th term, which is what I have written here. It is in notation form, the t n plus 2 plus n by 2 plus 1, which is the n by 2 plus 1th term. Now I have used the expression as I had discussed before, the terms tr plus 1 is the rth expression. So naturally we replace this r with n by 2 and we get the value of the m plus 1th term, and that is the middle term when n equal to 2m and n is an even number. Now let us consider an example when n equal to 2m plus 1, which is an odd number. So we can take into consideration a plus x whole cube. So in this case, the exponential is 3, which is an odd number. So again, since the exponential is 3, then the number of terms will be 4. So if the exponential is n plus 1, which is as we have if the exponential is n, then the number of terms will be n plus 1. And as we have assumed that n equal to 2m plus 1, in order to express the fact that n is an odd number, then n plus 1, which is the number of terms, will be 2m plus 2, because n is equal to 2m plus 1. Then n plus 1 will be 2m plus 1 plus 1, which is 2m plus 2. So we have 2m plus 2 number of terms in the binomial expansion on the right hand side. Now, if 2m plus 1 is odd, then 2m plus 2 will naturally be even. So we have an even number of terms on the right hand side of the binomial expansion. Again, as you know from this exercise, a plus x whole cube is a cube plus 3a square x plus 3ax square plus x cube. So we have 4 expansions. Naturally, there are 2 terms in the middle of the binomial expansion. So as you can see, I have written there are 2 terms in the middle of the binomial expansion. So we have 2 middle terms when n is odd. Again, for the middle case, for the 2 terms in the middle, there are m terms on the left hand side and there are m terms on the right hand side. So if there are n terms before the first middle term, then this will be the m plus 1th expression and this will be the m plus 2th expression. So we have, I just made a face out of here. Oh well. M plus 1th expression and m plus 2th expression are the middle terms. And going by the procedure that I had followed before, m plus 1th term, if n equal to 2m plus 1, then we can find out the value of m to be n minus 1 by 2. And we just make a small adjustment to make it n minus 1 by 2 plus 1 and n plus 1 by 2 plus 1. So we have the two middle terms and we express it as we had done before, replacing r suitably, and we get the middle terms. The next thing that we see is in an expansion, coefficients of terms equidistant from beginning and end are equal. We note that there is a rule in the combination chapter which we had discussed before, that NCR equal to NCn minus R. Now we move back to the expansions of the binomial expansion. You see, if this is the first term and this is the last term, then the coefficient of the first term and the coefficient of the last term is the same, because the coefficient of first term is 1 and the coefficient of last term is 1. So this is the first term. This is equidistant from the beginning, with the distance of the first term from the beginning and the distance of the last term from the end is same. They are both extreme numbers. Next, if we consider the second term from the beginning and the second last term, that is the second term from the end, you see the coefficient of second term is NC1 and the coefficient of the second last term is NCn minus 1. Now, as I discussed before, NCR is equal to NCn minus R. So NC1 will be equal to NCn minus 1. So you see the second term from the beginning and the second term from the end, these are equidistant from the beginning and the end. So coefficients of the second term and the coefficient of the second last term is the same. You can check with the other terms as well. So the coefficient of the third term and the coefficient of the third last term will also be same. In this case, it will be NC2 and here it will be NCn minus 2. So this is also a fact that we need to remember when we do chapters on binomial theorem, that in an expansion, coefficients of terms equidistant from the beginning and the end are equal. The final expression that we'll, not the final expression, one of the most important expression that we'll be finding out is the sum of the binomial coefficients of 2 to the power n is equal to 2 to the power n. So, sorry. Let's say we take into consideration this binomial expansion. So we have 1 plus x whole to the power n is equal to, in general, we write it as 1 plus nc1x plus dot 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 plus r plus 1th term is ncr x to the power r plus the final n plus 1th term is ncn x to the power n. Now, you might know that nc naught is essentially equal to 1. You can use the calculator or find it out otherwise, that nc naught is always equal to 1. So instead of writing 1 plus nc1x, I can also write it as nc naught or nc0 plus nc1x plus the rest of the expression. What I do is, since this is an identity, this should be valid for any value of x. So I replace the value of x with 1. So I get 1 plus x whole to the power n. When I replace x with 1, I get 1 plus 1 whole to the power n. Sorry. Again, on the right hand side, when we replace x with 1, nc naught remains nc naught and x becomes 1. So we have nc1 into x, which transforms into nc1 into 1. So we have nc1. Again, ncr, which is the r plus 1th term, ncr x to the power r becomes ncr 1 to the power r, which is again ncr. So naturally, we have this expression which says nc naught plus nc1 plus dot 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 plus ncr plus dot 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 plus ncn. Now, if you concentrate, these are basically the n plus 1 coefficients of the binomial expansion. Why n plus 1 coefficients? Because if this is 1, if there are 2, 3, 4, this is the rth and this is the nth expansion. So in between the bracket that I made, there are n terms, 1, 2, 3 up to n. And we also have nc naught. So we have a total of n plus 1 terms. All the more, when we have a binomial expansion of exponential n, we have n plus 1 terms on the right hand side expansion, and we did not cancel out any terms. We merely made these expressions simpler by exchange or replacing x values and a values with 1. So the number of terms essentially remain the same. I have not removed or added any number of terms. So we obviously need to have n plus 1 terms because the exponential is n. So we'll have n plus 1 terms on the left hand side. So you see, I found out that the sum of these n plus 1 terms is essentially 1 plus 1 whole to the power n, which was on the left hand side, and I transposed it to the right hand side and I get 1 plus 1 whole to the power n. which is essentially 2. We replaced x with 1 and we had 1 plus 1 whole to the power n is equal to nc naught plus nc1 plus dot 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 plus ncr plus ncn. And that is how we received c naught plus c1 plus dot 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 plus cr plus dot 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 plus cn equals to 2 to the power n. That is essentially what I wrote in the first step. The second step is, instead of replacing x with 1, I replace x with minus 1. So what I have is, I have 1 minus 1 on this side, and on this side I replace x with minus 1. So we have minus 1 on this side because it was nc1 into minus 1, so it becomes minus nc1. So we have a c naught minus c1. Again, as we have replaced x with minus 1, we have minus 1 whole to the power r on this side. Now, if the term is an odd term, then the exponential will be even, which means this minus won't be there. So for an odd term, the sign will be positive. But for an even term, this exponential will be odd and minus term will be there. So for an even term, there will be a minus in front. So if r plus 1th term is an even position, then there will be a minus. And if r plus 1th position is an odd position, then there will be a plus. So going by that procedure, we have 0 equal to c naught minus c1 plus minus 1 whole to the power r cr plus minus 1 whole to the power n cn. Next, what I do is I add this expression 1 and expression 2. So what I have is, I have 2n plus 0 on the left hand side, and that is what I I skipped a few steps. So what I have is, when I add these two expressions, I have on this side 2 to the power n, and when I add on this side, this c1 term gets cancelled, the c2 term remains, the c3 term gets cancelled. So I'm essentially left with the terms on the even position. So the odd positions. So we have the first position, the third position, the fifth position, and so on. Now you see, although the C2 is in the third position, it's C2. So we have C2 here, but this is actually the third position. This is the fifth position, but it's C4. So please don't get confused between even and odd. These are the sum of the even positions. The first position, the third position, the fifth position. But these are C0, C2, and C4. So please don't get confused with it. So the second terms and the fourth terms get cancelled because I have added, and there's opposite signs on this sides. So we get C0 plus C2 plus C4, which becomes 2 to the power n. Now, as we have added, we have 2 C0, 2 C2s, 2 C4s. So initially it was 2 into C0 plus C2 plus C4. So initially what we had 2 into C0 plus C2 plus C4. What I did was, I took this 2 on the denominator of the right hand side, that is, I divided both sides with 2, and I ended up with C0 plus C2 plus C4 equal to 2 to the power n by 2, which is essentially 2 to the power n minus 1. Similarly, I can subtract these two sides. So what I have when I subtract is, let me just remove this part, then it will be easier for me to explain it to you. So when we subtract the first equation and the second equation, that is, when we subtract this equation from this equation, what we are essentially left with is the opposite of what we had in the previous situation. So this becomes minus, this becomes positive, all these signs change. So the first position gets cancelled, the third position gets cancelled, but the second positions and the fourth positions are left. So we have the first position and the fourth, no, this is the second position. Yeah, again, don't get confused. This is the second position, this is the fourth position, this is the sixth position. So the positions and the numbers do not match. Always remember that the positions and the numbers do not match. If it's 1, 3, and 5, the positions are even. But if it's 0 to 4, the positions are odd. So when we subtract, we are left with the even positions. The second position, the fourth position, because the first, third, and fifth positions get cancelled. So we have C1 plus C3 plus C5 times 2, because we have added them. So C1 plus C3 plus C5 dot 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 times 2 equal to 2 to the power n, because that is what we are left with on the LHS. I take it on the right hand side, I transpose the sides, and I get C1 plus C3 plus C5 times 2 equal to 2 to the power n. Then I divide both sides with 2, and I have C1 plus C3 plus C5 equal to 2 to the power n by 2, which is 2 to the power n minus 1.